In this lesson, we're going to talk about the derivatives of inverse functions. There are technically two methods for how to do this, although even though method one is the method that makes the most sense, it's rarely the method that you're able to use on the AP test, and I'll kind of explain why. So essentially, the derivative of an inverse function, the easiest way to do it would be with method one, where it says simply find the inverse function, which you guys have known how to do for a few years now, and then take its derivative, essentially. So step one, to find the inverse function, you change x and y and solve for y. Step two, you take the derivative of your new function, and that is the derivative of the inverse function, and then plug in the value that you're being given. Obviously, that's the most logical of the two choices, but the reason why it's rarely the one you're able to use on the AP test is because they don't usually make the equations easy to take the derivative of, or they don't give you an equation, they just give you information about the function, and so that kind of leads us into method two and having to use method two. So we're going to practice more with method two today and discover a shortcut. So as we're doing the first three problems, I want you guys to notice, if you're able to, notice a pattern in it. So for method two, it says we're not going to find the actual inverse function because it's too difficult, or in this case, we're trying to explore. So the steps are to attempt to find the inverse by still changing the x and y, but this time don't solve for y. Instead, we're going to find the derivative of the function implicitly. So it'll be mixed up with x's and y's, and we'll find the implicit derivative. Then we'll solve for dy dx, we'll solve for the derivative, and the equation will be in terms of y. Now, I'll explain part D a little bit more thoroughly when we get there, because it makes more sense in practice than it does in words. But essentially it says to replace the value of k for x in your inverse function here in step A, and then solve for y. But like I said, I'll explain that a little bit more in detail in a minute. And last but not least, plug that value of y into the derivative and evaluate. So, let's go ahead and get started. For the first one, again, I know it's possible to take the derivative of this, to find the inverse of this and then take its derivative, but we're going to practice with method two. So we're going to pretend like it's too hard to take the derivative of the inverse of this by finding the inverse first, and instead, we're going to go ahead and attempt to solve for the inverse, but not complete it. So, to solve for the inverse, step A from the last page was to switch x and y. So we're going to say that this is x equals y squared. Now again, I know we know how to go through and actually take the inverse, but we're going to pretend like it's too difficult, and we're going to continue with method two. From this point, they want us to take the derivative. They said, okay, now that we have the inverse, because technically this is the inverse function, it's just that we haven't solved for y yet, but now that we have the inverse, let's go ahead and take its derivative implicitly. So step two is to take the derivative. The derivative of x is 1. The derivative of y squared is 2y times y prime. The next step was to solve for y prime, to solve for dy dx. So we have y prime equals 1 over 2y. Now, to find out the y value we actually plug in, we're going to come back up here to this point, and we're going to figure out what y is equal to when x is equal to 4. So essentially, I'm taking this value, and I'm plugging it in here to solve for what y would be equal to in this case. So if I do that, I get that 4 is equal to y squared. If I take the square root of both sides, I get that y is equal to plus or minus 4. Plus or minus the square root of 4, but because the values of x are positive, we're only looking at the positive half of the parabola, which would be positive x values and positive y values. So then we're just going to take the positive square root of 4, which is 2. So we're going to take that, and we're going to plug it in here. So when we do that, we get that the derivative of the inverse, which I'm going to call f inverse prime of x, is equal to 1 over 2 times 2, or 1 over 4. Alright, the next one. Again, step one is to switch x and y, so we put x equals the square root of y. I know it's possible to find the actual inverse, but we're going to pretend like it's not. Let's take the derivative of both sides. The derivative of x is 1. The derivative of the square root of y is 1/2 y to the negative 1/2 times y prime. If I divide both sides by 1 over 2y to the negative 1/2, divided by 1 over 2y to the negative 1/2, we get that y prime is equal to 1 over, and then if I simplify this a little bit, but I'm going to keep it on the bottom of the fraction. The reason I'm going to keep it on the bottom of the fraction should become apparent in just a minute, but I'm going to keep that as 1 over 2 and then the square root of y. Remember, to figure out what we're plugging in, I'm going to take this value and plug it in here so that I can go ahead and solve for y. So I get 4 equals the square root of y. If I square both sides, that means y is equal to 16. So I can take that and plug it in here. So this is 1 over 2 radical 16, which is 1 over 2 times 4, which is 8. And then finally, I'll go ahead and simplify this. That's just 8. All right, and last but not least, switch x and y. So x equals y cubed plus 1. Again, we'll pretend like it's too difficult to solve for y, so I will just take the derivative. That will be 1 equals 3y squared, y prime. And then the derivative of 1 is 0. Solve for y prime, so you get 1 over 3y squared. I'm going to evaluate what that y value is. So I'm going to plug in x equals 9 here. When I do that, I get 9 is equal to y cubed plus 1. Subtract 1, so y cubed is equal to 8. Therefore, y is equal to 2. So plug that in here. So y prime equals 1 over 3 times 2 squared, or y prime equals 1 over 3 times 4, or 1 over 12. Okay, so my question is, I'm wondering if you notice a pattern in any of these answers and kind of where they come about, because there's a little formula that we're going to learn. Because like I said, on the AP test, sometimes they might give you an equation that you're actually able to take the inverse of and then find its derivative. Sometimes they'll give you an equation, but it will be too difficult to take the inverse, so you have to do it this way. And sometimes they want to give you an equation at all, and it's important to know that little shortcut that we're going to learn in just a minute, in order to make sure that we are aware of where the derivative of the inverse comes about. So, I don't know if you guys have noticed any patterns, but one of the ones I want to point out is, notice the 1 over pattern. So it's 1 over something. On this one it's 1 over something. On this one it's 1 over something. So that's part of it. And then I want to know where that something comes from. So I want you to look back at the original problem and notice the derivative. What's the derivative here for x squared? It would be 2 times x. And notice here we have 2 times y. We plugged a number in for y, which happened to be 2. And we'll get where that 2 came from in just a second. Then for the next one was the square root of x. So it was 1 over, and the derivative of the square root of x is 1/2 x to the negative 1/2. So notice it's 1 over 1/2 y to the negative 1/2. And then for this one, the derivative is 3x squared. So it was 1 over 3y squared. So first pattern is that it's 1 over. The second pattern is that the bottom is the derivative of the original function, but in terms of y instead of in terms of x. And the last thing I want you to notice is the number they're plugging in. So this x equals 4, they're not plugging that into the derivative that's on the bottom because it's in terms of y. The number that we're plugging in here is what we would get if it was the inverse function. So essentially, if you switched the x and the y, if I plugged in 4 to that, what would the y value be? If I'm looking at points, like if they didn't actually give me the equation, if they just gave me points for this first one, for example, they could have said like f of 2 is equal to 4. If they told me that f of 2 is equal to 4, then I want you guys to remember that a property of inverses is that inverse functions have all their coordinates switched. So then f of 4 would be equal to 2. And so essentially what we're doing is we're trying to find the value from the original function, plugged into the original function, what y value is it giving me, and that's the value that I will plug into my final equation. So anyway, that's a lot of words to summarize and say this is the shortcut. And I want you to add in that g and f are inverses. So given f of x, or sorry, g of x is the inverse of f of x, then this holds true. So if I know that two functions are inverses of each other, the derivative of the inverse would be 1 over the derivative of the original function, but evaluated at g of the number rather than f of the number. So write that down and let's do some examples. Alright, all these examples come from previously released AP tests because I want to show you guys what the problems look like on the AP test. Notice, by the way, that each one's from a different year, so typically there's only really one question per year on this topic. It's not a huge topic, but it's an easy point if you're able to remember this formula. It says let f of x equal 2x plus 1 cubed and let g be the inverse of the function f. Given that f of 0 equals 1, what is the value of g prime of 1? So remember, that little formula we just wrote down, g prime of 1 is equal to 1 over f prime of g of 1. That's the little formula we just wrote down. So I need to know the derivative of f, and I need to know what g of 1 is equal to so that I can evaluate this. So first let's look at the derivative of f prime of x. So the derivative of this requires the chain rule. So the derivative of the outside, which is I cubed, is 3 times I squared, and the derivative of the inside, which is 2x plus 1, would be 2. So this is 6 times 2x plus 1 quantity squared. So that goes in the bottom of this fraction. It's 1 over 6 times 2, and then I'm going to put a little blank there for right now, 2x plus 1 quantity squared. The reason I'm putting a blank there for right now is because this x is not the same as, is not the same as this x. I want to plug in g of 1 here. So here's what I mean by that. If f and g are inverses, I know that f of 0 is 1, and if they're inverse functions, then g of 1 would be equal to 0, because remember these just flip-flop in the inverse. So g of 1 is equal to 0. So that's what I'm going to be plugging in here to this blank. I'm not plugging in the number from here, I'm plugging in what it's equal to on the inverse function. So I'm plugging in a 0. If I evaluate this, I get 1 over 6 times, this would be 2 times 0 is 0, plus 1 is 1, 1 squared is still 1, so it's 1 over 6, which is answer choice D. Next question. Alright, this one's from the 2008 AP exam. Notice, by the way, they're not giving us an equation at all. They're just saying let f be a differentiable function, and they're giving us a bunch of information. F of 3 is 15, f of 6 is 3, f prime of 3 is negative 8, and f prime of 6 is negative 2. It says the function g is differentiable and they're inverses of each other. What is the value of g prime of 3? So let's come back to our little equation. Our little equation says that g prime of 3 is equal to 1 over f prime, the inverse derivative prime of g of 3. So I first need to know what g of 3 is equal to. So anywhere up here in these directions, do you see g of 3 equals? I don't think so. I see a lot of f of something equals, but nothing that says g of something equals. So again, let's use our knowledge that g and f are inverses. And instead of looking for g of 3, let's look for f of something equaling 3. So here I have f of 3 equals 15, not that one. Here I have f of 6 equals 3. Ooh, okay. So if I look at this one, on the inverse, these coordinates are flipped. So on the inverse, that would be g of 3 is equal to 6. So I know that I'm plugging in 6 here. So this is 1 over f prime of 6. And let's look in our directions again. Do I know what f prime of 6 is? Yes, f prime of 6 is right here. It's negative 2. So this is 1 over negative 2. That's answer choice A. Next question. 2003. Again, notice that we're hitting on 1 from every test. They don't have more than 1 typically. And these are pretty much all the different ways you'll possibly see this one asked on the AP test. It says let f be the function defined by f of x equals x cubed plus x. If g of x and f of x are inverses and g of 2 equals 1, what is the value of g prime of 2? So let's pull out our little mini equation. G prime of 2 is equal to 1 over f prime of g of 2. All right, so I need to know the derivative of f, and I need to know g of 2. Well, this time they were nice to me, and they actually gave me g of 2. They said g of 2 is equal to 1, rather than making me figure it out from the function f. So all I need to know now is the derivative of this, and the derivative, f prime of x, is equal to 3x squared plus 1. So this is 1 over 3 times the number squared plus 1. And the number I'm plugging in is g of 2. And they said here, g of 2 is equal to 1. So this is 1 over 3 times 1 plus 1, which is 3 plus 1, which is 4. 1 over 4. Answer choice B. The next one. I think this is our last one. Yes, it is. I don't think this was from an AP test. This is just from a different test bank I found. But it says, given that S is the inverse of F, then find the derivative of S at 3. So again, using our little teeny tiny formula, S prime of 3 is going to be equal to 1 over the derivative of its inverse, which is f prime of s of 3. So I need to know what s of 3 is equal to. And remember, if they're inverses of each other, f and s are inverses, then if I want to know s of 3, if I want to know what that equals, then I should look for f of some number is equal to 3, because I know that those are flip-flopped, remember? So I'm looking for what that question mark is based on this. So I'm saying, what number did I plug into f to make it equal 3? So here's f, and it equals 3 when I plugged in x equals 1. So f of 1 is equal to 3. F of 1 is equal to 3. Therefore, s of 3 is equal to 1. So over here, I'm going to write 1 over f prime of 1. And looking back at our chart again, f prime of 1 is equal to 2. F prime of 1 is equal to 2. So this is 1 over 2. Answer choice D. And that's the end of the lesson for today.